Okay, so let's start off from something that we know to be true. 6 divided by 2 is 3. So 6 divided by what is what? Well, I can shuffle those numbers around and I can put the 3 down here and I can put the 2 up here, and I get effectively a true statement, which is still true, using the same numbers. Now, what actually have I done? Well, I've actually just swapped over those two numbers. The 3's come down below, the 2 has come up above. In effect, I'm multiplying both sides by 2 to shift that one up. I'm dividing both sides by 3 to put that one down. So just applying it to simple numbers tells you that that works. Now if I chuck a variable in, like the letter x, does the same thing actually work? Well, 10 divided by x equals 5. If I asked you to solve that particular equation, I think with a bit of trial and error you could end up with x equals 2. The reason why that is the case is, again, I'm allowed to switch those two over. And in fact, if I put the 5 down below, down here, and the x up at the top, it actually does my solving for me, because 10 divided by 5 is indeed x. Effectively what I'm doing is multiplying both sides by x to remove the fraction from underneath, and then dividing both sides by 5. If I show you that, really what I'm doing is starting off with 10 over x equals 5, and I'm multiplying both sides by x. That will cancel. That gives me 10 equals 5x, and then to remove the coefficient from here I would divide both sides by 5 to end up with x equals 2. So that's the maths behind the situation, and using the do the opposites to both side method still gives me a true statement. So supposing I do a compound, what's called a compound denominator, because there is more than one thing underneath. Will the switching method still work? Well, in fact, it's always a good idea, if you've got more than one item underneath, more than one part to your term, is to put a little bracket around it. Then I'm going to do a switching process, and I'm going to end up with the 2 underneath on the left hand side and the x plus 1 on the right hand side. If I then carried that through to its logical conclusion, I could do 8 divided by 2, which is 4, equals x plus 1, and take 1 from both sides, and you'd end up with 3 equals x, or x equals 3. Is that actually correct? Well, if I substitute 3 in here, 3 plus 1 is 4, 8 divided by 4 is 2. Okay. Now what I'm doing really with that equation is, to clear this fraction out on the bottom, I'm actually multiplying both sides by x plus 1. I've done the switching over process and that's fine, and because I can do 8 divided by 2 is 4, that helps me. But in effect what I'm actually doing is multiplying both sides by x plus 1, this term which is underneath at the bottom. If I do that and follow it through and multiply both sides by x plus 1, of course that will cancel, giving you just 8, and you end up with 2 lots of x plus 1 on the other side. And of course then if I open the brackets, I would get 8 equals 2x plus 2, and if I subtract 2 from both sides, I get 6 equals 2x, and then divide both sides by 2, and x equals 3, which is what I had before. It's the same method applied in just a slightly different way. Just straighten the camera up a bit. So, the hardest ones you're likely to come up against are ones that look like this. Again, what I'm going to do is just put a little bracket round the compound denominator on the right hand side, and effectively what I'm doing is multiplying both sides by x to shift this little fella out, and then I'm multiplying both sides by x plus 1 to shift this little fella out. And the purpose of the title, the double switcheroo, is that effectively I can do this. That is just going to come up here, and that is just going to come up here. And if I do that, I get 6 lots of x plus 1 equals 4 lots of x. and I could finish that off in the usual way by opening the brackets up, collecting like terms, subtracting the same thing from both sides, and I'll end up with my answer. Should we just do that? So finishing off, I would open the brackets up to get 6x plus 6 equals 4x. And I'm going to subtract 6x from both sides. And that gives me 6 equals negative 2x. And then I divide both sides by the coefficient. That will cancel. X on this side, negative 3 on that side. So the answer is x equals negative 3.